Right, longevity risk. So this paper will discuss some issues around longevity risk and socio-economic categories. So this first slide kind of shows what we're talking about. So when we talk about longevity risk, we have the risk around base mortality, so that's data risk, selection risk, and then we have the risk around mortality improvements, and that includes trend risk, basis risk, and then the question we're talking about is how do socio-economic circumstances may have an impact on mortality improvements. So we're really talking about mortality improvements and trend risk in particular. So this presentation will have 6 main messages. So I've boiled down the paper into 6 main points. 4 of those are more descriptive, trying to interpret what we observe. And then the last 2 points will be more like, okay, now that we've made some observations, what do we do about it as an annuity provider, and what should we do in terms of risk calibration once we've looked at the data. So first key message, the golden cohorts enjoyed high mortality improvements due to advances in modern medicine, but also as a side effect of the reduction in socioeconomic inequalities in the middle of the 20th century. And so that's something that was touched on yesterday when there was a first session on demography, and it was shown that the cohorts born around 1930s enjoyed really high life expectancy increase compared to other cohorts. They were called the golden cohorts, and they've seen higher rates of mortality improvements compared to other cohorts. So why is that? So there's been some discussions around that. Few explanations could be healthcare, nutrition, reduction in smoking prevalence, and all those explanations make sense, so that they all contribute to the answer. But another thing to consider is that the golden cohorts were working adults in times of low socioeconomic inequalities, where the share of the national income was relatively high for labor and income inequality was at a low point in history. And these are graphs that I've found on various official sources. The ONS is one. So on the left-hand side, you have the share of labor in the national income in the UK. And as you can see, there's a big jump after World War I, and it stays relatively high for a long period of time until basically the 1990s. And then on the right-hand side, you have the index of income inequality, or Gini index, and it tells a similar story in that it shows that after World War I, after the 1930s Great Depression, the income inequality was really low and stayed low until the 1970s, early 1980s, and that's in the US, but it was the case in other developed economies. And that's to show that if you were going to be born working class from a deprived background, and you could choose to be born any time in history, actually this time, the 1930s, were actually a good time, because you would be working in an environment with a greater proportion of the wealth distributed to labor. The paper argues that this has contributed to higher mortality improvements, and that was between the 1940s or up to the 1980s. And that was a time of great catch-up for the more deprived groups in terms of not just income, but also in terms of life expectancy. Key message 2, rising income inequality in the UK coincides with higher mortality inequalities between socio-economic groups. And it is very much related to the first message. The increase in income inequality in the 1980s in the US and in the UK, so that's the deindustrialization periods, was followed by high mortality inequalities. And there's an example of the UK on the left, where if we look at the ratio of period life expectancy, so in the early 1980s, so the wealthy quintile was living 6% longer than the more deprived quintile, and now about 40 or so years later, the wealthy quintile lives about 40% longer than the more deprived quintile, to show that there's been a divergence between socioeconomic categories. And on the right-hand side, you have the Gini index of the UK, showing that if you look at the early 80s up to now, there's been an increase in income inequality. And the paper argues that these two things are, well, they're not only correlated, but they're actually very much a link to each other. So higher income inequality leads to higher longevity inequalities. And so as I mentioned, the golden cohorts where inequality was low, from the cohorts born in the 1960s, we see the reverse happening. So more inequalities for people born in 1960s, with very high unemployment rates when they enter the labor markets in the 1980s, with very high unemployment levels at that period. And then by the time they reach their 50s, they found themselves in the post 2008 global financial crisis austerity era. And again, this is a period of high inequality. And so this is what I call the trouble cohorts. So they've been through a rough patch of unemployment, austerity, and we see their longevity improvements being much lower than the previous generation. Rising income inequality means some groups continue to live longer, but then a group of people fall behind in terms of life expectancy. So it doesn't mean, that no one's living longer. It just means that there's greater inequality. Key message 3, differences in mortality are driven by differences in lifestyle, with prevalence of smoking, obesity, and alcohol use among significant drivers differentiated by socio-economic groups. And so that's something that was discussed yesterday in one of the sessions with Andrew Kent's talking about these issues. And so one such example is smoking prevalence going up in the 20th century and then going down. But what we see is that it started as a lifestyle for the affluent groups, but today in the UK and many other countries, smoking is associated with the more deprived categories. And the more affluent groups are 2 to 3 times less likely to smoke than the more deprived groups. And this has a direct effect on lung cancer mortality by socioeconomic group. And we can say the same thing with obesity. And here I found a graph showing the obesity prevalence by IMD deciles. So IMD is the index of multiple deprivation. So that's an indicator of deprivation by postcode. And what this graph shows is that if we look at obesity level by socioeconomic category, the more deprived groups are twice as likely to be affected by obesity as the least deprived category. So that's also the case around liver disease mortality, where there's a socioeconomic element to the issue. And these lifestyle health issues are twice as prevalent for the more deprived groups compared to the more affluent groups. So many drivers of mortality have an observable socioeconomic element. Causes of death analysis show that some causes like lung cancer, suicide, substance abuse have a very high association with socioeconomic groups. And here, this is the hazard ratio, so the ratio of mortality by socioeconomic groups. So on the left, this is the more deprived groups with higher mortality. On the right, this is the more affluent groups with lower mortality on average. The big blue dots, that's the all-cause mortality level. And as you can see, if you break down the all-cause mortality into different causes of death, you see that there are some causes of death with a very high association with socioeconomic category, such as lung cancer, suicide, and substance abuse. And then other causes of death have a very low association with socioeconomic categories, and such as dementia and cancers other than lung cancer. Key message 4, more affluent groups are characterized by stable mortality compared to the general population, and the volatility of the general population mortality is mostly attributable to the more deprived socioeconomic groups. And at first, this was more of a intuitive thought. You know, the idea that the more deprived groups are more affected by unemployment levels, social care, funding, access to healthcare, lifestyle, and whereas the more affluent group of people were less affected by economic issues. And when we look at the data, it turns out that when mortality improvements are strong, they're especially strong for the more deprived groups. And when mortality improvements are weak, they're even worse for the more deprived groups. So divergence between socioeconomic groups is really about the more deprived groups catching up or falling behind, whereas the more affluent groups have a more stable, less volatile mortality improvements. Key message 5. So now we're getting into questions. So now, what do we do about it? From a risk management point of view, mortality trend is not adequately assessed by looking at the general population, but instead by looking at the subsets of the population that matches the more affluent profile of the annuitants. So here's what we don't want to do. What we don't want to do is use the general population, fit a stochastic model on it, projects future mortality improvements, and apply that to our book of annuitants. Typically, an annuity portfolio is exposed to more affluent socioeconomic categories, if not in terms of policy numbers, at least in amounts. So during an economic downturn, annuitants will do better than the general population, while during an economic boom, the more deprived groups can do better than the annuitants. And this can change the shape of cohort effects when we project mortality improvement in the future. Therefore, it is essential to calibrate mortality improvement and the risk around it using a population that is more relevant to the longevity exposure that we have in the annuity book. Key message 6. Trend risk can be calibrated with a smaller subpopulation without adding volatility, because the more deprived groups that are typically not well represented in an annuity portfolio are also the main contributors to volatility. You may think if we reduce the size of our data sets, we might find that we lose diversification between socio-economic groups, and from a risk point of view, we have more volatile mortality improvements. It turns out it is not the case. If we exclude the more deprived groups from the data, the mortality trend that come out of the calibration is actually less volatile than that of the general population. So to conclude on longevity risk and socioeconomic considerations, these are two graphs that kind of illustrate what I've been talking about. So the way to read those graphs, so from left to right, you have the socioeconomic mix. So on the left, you have the more deprived 10%, and then as you go towards the right, you get the more deprived 20%, and so on. Then once you get into the middle of the graph, you have the whole population, so the 100% of the population, and as you go towards the right again, then you start excluding the 10% more deprived, then the 20% more deprived, all the way to the right, where you have only the 10% more affluent group. So from left to right, you have a gradual increase of affluence. And the pink bar on the right represent the number of deciles by socioeconomic group. So on the left, you only have a small population size because you only have the most deprived group. As you go towards the right, you increase the size of the data sets, and as you go right again, you decrease it towards the more affluent groups. The blue bars on the left represents mean improvements over the observation period. So that's the mortality improvements. So as you can see, the deprived categories have, on average, lower mortality improvements over the observation periods, which is from 1980 to 2019. And around the 40% more affluent group of people have the highest mean mortality improvements. So these are the categories that have enjoyed the highest average mortality improvements. And then the dotted lines represents the confidence intervals, assuming that mortality improvements follow a normal distribution. On the right, you have the corresponding 1 in 200 mortality improvement stress by socioeconomic group. So that's, if you're doing Solvency II sort of calculations, what is the stress on mortality improvements that you would apply on all these different groups by socioeconomic category? So it reduces as you increase the size of your subset. So on the very left, you have a very high stress, and that's mostly to do with the fact that the sample is very small. And then the stress reduces as you increase the population size. But but interestingly, it doesn't go up when you reduce the size towards the more affluent sides. So when you go past the point of middle affluence, when you go towards the side of more affluent people, what you see is that the stress actually continues to reduce, and that's because the mortality of these socioeconomic groups is less volatile than the general population. So the reason for that is when you remove the more deprived groups, you make mortality improvements more stable. So you can calibrate your trend risk on a smaller, more affluent subpopulation, so typically your annuitants, without increasing trend risk. And that's the final thoughts on this presentation. And thank you very much.
Thanks, Philip. So just an interesting question here. In the US, the lowest quintile has had worsening mortality termed deaths of despair. Is this also the case with some other countries?
So I can mostly talk about the UK. So what we see in the UK at present is we also see a worsening of life expectancies. And as was talked about, I think it was yesterday, so in the US is mostly to do with the younger population. In the UK, it's to do with mostly cardiovascular risk, and it's affecting the older population, but more worryingly the adult population, so 50 plus, and it's becoming an issue. I think in the US, they've reached a level of that they've seen the effects of the increase of obesity in full. I believe that in the UK it is happening at the moment, that there's a double effect of the long-term effect of obesity levels coming to coming to be seen in the mortality rates, and the other effect also is the issue of the National Health Service, which is under huge pressure for various reasons, and that's also another reason why we've seen very slow mortality improvements in the UK. So I believe it's different issues.
Yeah. Thanks, Philip. Another good question here, has any similar research been done in developing economies? And if so, do we observe similar trends to the UK?
Yeah, so again, it's very difficult for me to comment on developing economies, but what I can say around that is that in developed economies, we look at, well, I've looked at the trends in longevity around across periods from, say, the 1930s until now, and things like change in smoking prevalence and number of different things that have happened in the UK. When you look at developing economies, my understanding is that everything has gone really fast. So, in some countries, like 50 years ago, they still had mortality due to infant mortality, infectious diseases, and then it all happened very fast. That they had a very fast improvements due to infant mortality reduction, use of antibiotics for infectious diseases, treatments for cardiovascular disease, heart, cancer as well, and then smoking prevalence also is one that has shown very different patterns. So it all happened very fast in some developing countries. So that's why it's very difficult to compare what we've seen in the developed economies since World War II to what's happened in some developing countries.
Yeah. So, Philip, just another question that's here that I think would be good for you to comment on quickly, because this is also a question that I asked you when I met you, because you're involved obviously heavily in the design and measurement of mortality in these annuity portfolios.
Yeah.
Are insurers allowed to price based on socio-economic category?
Are they allowed to price based on socioeconomic? Well, I mean, firstly, they're allowed to price on objective metrics, such as you can objectively use the postcode, for example. But then, if you start asking someone what's your level of education, I'm not sure you're actually allowed to ask that sort of question to your client. So I believe this is more around data protection, data use, rather than socioeconomic category. Because like the question is, how do you define a socioeconomic category? Is it postcode? Is it education? Is it income? So you can always price on objective data that you're allowed to gather, and that's perfectly acceptable. But if you're not allowed to collect the information, then obviously you're not going to be able to price on it.
Yeah, okay. I'm getting a lot of questions coming through, so thanks everyone in the audience. Some questions, Philip, around how do you handle, like you've got these IMD indicators of socio-economic bands, but how do you handle upward mobility in some populations? Like some people are obviously transferring from category to category.
Yeah. How do I deal with that?
Yeah. Or just general comments.
General comments. I mean, it's definitely an imperfect measure because in the UK this is provided by the official National Statistics source, and it's by postcode, and then they look at a particular postcode, and they look at a number of different things, such as average income and level of education and a number of things. But it is an imperfect measure. I mean, you know, probably example of living in a very deprived area where I don't really represent the typical person who lives in that area. So that's because I very much have the intention to buy an annuity from that place rather than from a more affluent postcode. But it is very much an imperfect measure, and I think we have to be aware of that.
Okay. Would the volatility observation still hold with significant change in socio-economic inequality, either much greater or much less inequality?
So I think that's a key message in the paper, which I would invite you to read, is that it's the idea that if you reduce inequality in a population, then you reduce the volatility of mortality risk. And it's the idea that as we've seen increased inequality levels, in particular in the UK, we've also seen increased inequality of mortality outcomes. Was that the question? Yeah.
Okay. I think there's a question here also around, like, it must be difficult given, as you said, this sort of point about the golden cohorts.
Yeah.
I mean, studying this stuff, surely there's some kind of longitudinal bias that could potentially be an issue because you're only able to study, for example, we're only able to study and understand mortality improvements potentially in cohorts that have, benefited substantially. How do we deal with that?
How do we deal with the...
Like, for example, the bias that could be present in our understanding of future mortality improvements because of the golden cohorts being, say, in the observational data.
Right. Well, I would say that's, for example, what the CMI model does by by separating cohort effects from the improvements that were observed, so that the model can deal with what's attributable to cohorts, in this particular case the golden cohorts, and then what's attributable to the periods, and that's what the model attempts to do. And I'm aware that, you know, it's not the only model, but it's probably the most established model, at least in the UK. It's certainly the most established model.
Okay, thanks, Philip. Yeah, thank you.
Thank you very much.